so here we go. The answer is this. A negatively charged insulated strip is brought close to a neutral pith ball, but they do not touch. And there you have it. Right away, that is the big hint to look for to tell you that this is electron shifting. So number 4 would have been the correct answer. So why is that? In all other options, charging by friction, charging by contact, and grounding, the two objects touch. Electron shifting is the only scenario where the two objects do not touch, okay? So now we're going to work through this example together, all right? So these two objects are brought close, but they do not touch. Now, I wanna show you guys some advice that that the CP physics teachers and I, we've kind of thought of and come up with that I think will be helpful to you. So let's start with this. We're gonna draw the insulated strip and we want to draw the diagram for it. We see that it's got, I'm going to draw this one for you. It's got 10 atoms and a charge of -4. So we know that that means it's got 10 protons. And if it's a charge of -4, it has 4 more electrons than protons, so 14 electrons. Now, watch this. One thing that we want to recommend you do is, instead of drawing pluses and minuses, just draw red circles and green circles. And you can do it just by choosing maybe like a larger, thicker, pen, and so we're going to do like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so now we've got our 10 protons, and now we got to do 14 electrons. So then I go back here, I pick my green for my electrons, maybe zoom in a little to help you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we need 4 more electrons. And we know those electrons, because this is an insulator, right? Because this is an insulator, we know that those 4 extra electrons are going to stay where they were originally, where they were put. And we know that we put them by this star. So we need 4 electrons near that star. So I'm going to go like 1, 2, 3, 4. So I'm going to give those 4 the extra electrons. The last thing to remember is make your pen kind of like skinnier again, and then circle the neutral guys. So this guy, this guy, this guy, this guy, this guy, this guy. Okay. So now I'm going to give you some time, and I want you to try and do this, this, and this. Try and do those 3 and give me a signal once you've done them. I really recommend that you practice just doing the green and red dots. I think it makes things a lot easier and faster than drawing like red pluses and green minuses. So I'll be patient, and I'm going to let you just give me a signal, you know, throw me an emoji or whatever when you have tried to draw the diagrams for those 3 things: the pith ball before, the insulating strip after, and the pith ball after. Thank you, Jolie, Azima, and Angelo. I see you 3 have done it.
I actually just have a question.
Oh, sorry, go ahead.
So why would you have the like 4 extra electrons attached to the other ones? Would you not have like 10, I guess, like the 10 where it's like the green and red, and then the 4 extra electrons, so the 4 greens surrounding the star? Like, why do they connect to the pre-existing like atoms already? I don't know if that made sense.
Well, no, usually electrons are connected to some sort of atom. Now, you don't have to do it that way. Like, you could have just had them in that general area. We're not being super picky about that. But if you think about, like, electrons are usually connected to an atom. So I'm just connecting them to atoms. Does that make sense? Like, they're in an atom shell. They're in.
Okay, so like I originally drew like the 10 sets of the red and green, and then I just drew 4 extra green dots around the star. Would that still be like, I fixed it to what you have now, but is that still like an accurate answer?
I'd be okay with that. Yeah.
Okay.
Okay. Good question. Thanks, Julie. Can I do a quick double check-in? So if you already signaled, can you signal again? How many people have finished drawing these 3 things? Give me a sense. So, all right, thanks. Angelo, Megan, Michael, Rabab, Arad, Sebastian, Mara. I'll wait just another minute. Ethan too. Thank you, Ethan. Okay, then I'm gonna dive in and I will do these. Okay, so the pith ball is neutral and it's got 10 atoms, so it's gonna do 10 protons and 10 electrons. So I'm gonna go and make my pen a little bit thicker and do my red protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'll throw my green electrons in there, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is, you can see that like I was a little sloppy with it, but that's why circling is so important. So make it a little skinnier for circling. Because now I know that, okay, these were all supposed to be neutral, even though some of these look like they've got like 2 protons. The circling tells me, no, just supposed to be 1 and 1. Okay. Give me a signal if you did that one right. How many people did that one right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So like exactly half of us. Okay, cool. Good job. Anybody got any questions? So let's do the insulating strip. Now, one important thing is this: since the strip is an insulator, it holds its charges in place. They can't shift. So here's another helpful tip as far as doing this. I'm just going to copy and paste it. So copy and paste it because it's going to stay the same. Now what you can do is you can take 2 fingers and rotate it like so. And then there you go. So give me a signal if you kept the insulated strip the same. How many people kept it the same correctly? Give me a signal if you did that. 1, 2, 3, 4, 5, 5, 6. Okay, 6 of us. So fewer of us, but hopefully that makes sense now that you see that. Hopefully that makes sense. And now the pith, and so that's because it looks exactly the same, again, because it's an insulator. And insulators don't let their electrons move around or their charge move around. Now, the pith ball, you should remember, is a conductor, so it does let the charge move around. So I'm going to go and copy and paste it over again. I think that's a really handy tool and kind of saving you time. And then I'm going to go in and edit it and modify it. And what I see is that the insulated strip is negative here, right? It's got extra electrons. So that is going to shift the electrons that are close to it away. So these electrons are going to get shifted away. They're going to be repelled, right? Because opposites attract, but likes repel. So I'm going to go in here and I'm going to take this electron. I'm sorry, I'm going to grab this electron, shift it over, maybe like to there. And then I'll grab this electron right here. See if I can get it. There we go. And I'll move it maybe over here. It's getting repelled away. And then same thing with this electron right here. All the ones that in my mind are close to the strip, I'm going to repel them away. All right. And so then this is no longer neutral. That's no longer neutral. And that's no longer neutral. All right. Give me a signal. Did anybody draw the pith ball correctly with those electrons being repelled away from the strip?
I have a quick question.
1, 2, 3, 3 was. Yeah, go ahead, Azima.
I was wondering, like, are you gonna go back to drawing them as like pluses and minuses, or are you just gonna keep drawing them like
I'm
this
going to
way?
do it this way. And like, if you want to do pluses and minuses, you're more than welcome to. I just think it's faster to do it as just green circles, green dots and red dots.
Okay.
Yeah, I'm just trying to give you some tips.
Because like I get confused sometimes because it looks like there's 2, or just like the way that you draw them. Like,
exactly. Totally. And that's why I was saying that these circles are so important. Because whenever you see the circle, that's me saying there's just one of each. That's what the circle means.
Mr. Bosday?
Wait, sorry, is that good enough for you, Zima? Does that help?
Yeah.
Okay, good. Jordan, go ahead.
So for after the electron shifting happens, can't you just move all the electrons over, or do you only move the ones?
Yeah, yes. So I just moved 3, but if you want to move more than 3, that's fine.
So you could basically, like, if you kept it the same, you could have like 3 neutral atoms and have like 7 extra electrons scattered around on the far right.
Yes.
Okay.
I have another quick question. I'm just
Yeah,
making sure that the red ones are the protons, right?
that is correct.
Okay.
Good. Thank you. That's an important question. Thank you. Any other questions out there? Okay, so let's see then. What we've got is this is still neutral because nothing happened, and both are still neutral because no charges transferred. Right?
What did the insulators remain
Hold on.
negative?
Let me just finish this. Oh, yeah, you're right. I'm sorry, Rod. Thank you. This is what I was trying to say is they're the same as they were before. And so this is a charge of -4 because it's 10 and 14. And this is neutral because it was neutral before. So 10 and 10. But the point is they're the same charges before because no charge is transferred. Thank you. Now, let's do this. In the chat, send me a direct message if you think, now that you see how these are going to look when they're brought close but not touching, do you think they're going to A, attract, B, repel, or C, neither attract or repel? So direct message in the chat, give me an A, B, or a C. Let me know what you think is going to happen to those two guys. Are they going to attract, repel, or neither? Let me see. Scroll down so I can see what we're thinking. So there's A, B, or C. Again, as always, don't feel embarrassed about getting it wrong. If you get it wrong, it's just going to help you pay more attention and learn from your mistakes. So everyone should guess, and you can just send it directly to me. Okay, so the answer, and our people's guesses are kind of all over the place. There's no clear winner in my mind. And so the answer is this. Because the strip is negatively charged and the side of the pith ball that's closest to it is positively charged, they are going to attract. So again, because the strip is negatively charged and the side of the pith ball closest to the strip is positively charged, they're going to attract each other. All right. So
But
now I want
you to tell initially, like to get the electrons on the far right side, didn't they need to repel?
So what repelled was the electron. The electrons repelled, yes, but that's not going to move the actual pith ball because the pith ball is so much bigger than those electrons. So the electrons move to the side, shift away, but that's not going to actually make the pith ball move. What
So
is going to
this is basically asking, after everything happens, what remains? Will it attract or repel in this current state?
Exactly. Okay. Yeah. And so now that the side's positive and this whole thing's negative, they're going to attract each other. Good.
So even though like the overall charge of both of them is like not negative and positive because the side closest is positive.
Perfect, Julie. That's
Okay.
exactly. Yeah, exactly. Yeah, you guys are really getting this. Any other questions out there? So now I want you guys to practice the explanation. Okay, and I'm going to give you a teeny little like guide for that. First, talk about why the pith ball ends up this way. Then talk about why the strip ends up that way. And then third, and finally, explain why they attract. Okay, so I'm going to give you a head start. Then I'm going to start writing. And then when I'm done, we'll compare and contrast what you said and what I said. So I'll give you about 1-2 minutes to get a head start on writing that. Just to maximize our time, I'm going to start writing. So you're welcome to take a peek at what I'm writing, but if you're still writing, please just keep rolling on your own, okay? All right. Let's do some check-ins. Give me a signal if you said that first thing. Because the strip is an insulator, the charge won't shift and it will remain the same. Give me a signal if you said something about the strip's an insulator, so it'll look the same. It'll remain the same. Who did that? Give me a signal if you said something like that.
Mr.
Okay.
Bozada, you didn't require us to do it in the prior formative.
I think I did. So, but just, that's okay. We can double check, but for now, I just want to make sure we touch on that. So then give me a signal if you said the second thing, because the pith ball is a conductor, the electrons will be repelled by the negative strip and shift away from the strip. Give me a signal if you wrote something like that, that the pith ball is a conductor, and so the electrons will shift away from the negative strip. Oh yeah, for sure. I mean, words you would want to use the word conductor and shift away. Those are the two, those are like the key. If you have the word conductor and shift away, bless you, those would be important. And then finally, give me a signal if you said the third thing, since the strip is negative and the side of the pith ball closest to the strip is positive, they will attract. How many people said that? Good, good, good. Good, good.